So let f and g be two continuous functions at x equal to a. Then you multiply f with a constant. The function continues to be continuous at x equal to a. All right. Because f and g are continuous, the sum f of x plus g of x will be plus or minus g of x will be continuous at x equal to a. And the product will also be continuous. The ratio f of x over g of x, this will be continuous at a provided g of a is not 0. If g of a is 0, at that point it becomes discontinuous. Okay. Now, next, this part is very simple. All the first four. Then these three are part of what is called as the intermediate value theorem. And these are extremely useful for finding the roots of equations. Okay, they are very roots of equations of any type of functions, not just polynomial or algebraic, any type of functions. They're very useful. So what this property says is if f of x is continuous on AB such that, okay, such that f of a and f of b are of opposite signs, then there exists at least one solution of the equation f of x equal to 0 in the open interval AB. So here we have, let's say, okay, you can have a negative sign also. Now, let's say this is the interval A, B, and f of A, if f of A is positive, f of B is negative. Let's say f of A and f of B are of opposite signs, which means f of A into f of B is negative. Product is negative means they are of opposite signs. Sometimes it is said in this language, in verbal, f of A and f of B are of opposite signs, or it is mentioned in this mathematical language, f of A into f of B less than 0. And function is continuous. Because function is continuous, what happens? You have to join these 2 points with a curve without a break. You don't, no matter what the function is, it increases or decreases, but then you, without lifting the pen, we have to join these 2 points, f of A and f of B. This is f of A and f of B. Because the function is continuous, you will have to cross this x-axis, and this curve will necessarily cut x-axis at least at one point, if not more. At least. They can be more also, like this. I will draw. It can cut like this also. So they can be 3 points. In the previous case, there was only 1 point. Here there were 3 points where it cuts. So the thing is, f is continuous. F is continuous on closed interval AB, and f of A and f of B are of opposite signs. Then there exists, the sign is for there exists at least one x belonging to AB such that f of x is equal to 0. So in other words, f of x will have at least one root in AB in this open interval. F of A is not equal to 0, f of B is not equal to 0. So at closed interval AB is meaningless in the open interval AB. Okay, this is the intermediate value theorem, which is very, very useful, extremely useful theorem for solutions of equations. If we have to identify the solutions, we substitute different values in the function, and if those function values are of opposite sign and the function is continuous, then we know that there will be one root definitely in between them. Now next, if f of x is continuous function such that f of f maps AB to AB. Okay, this is just an extension. Now this is the domain and this is same as the codomain. Okay, okay. So function, graph of the function will exist within this box, within this region bounded by these 4 lines. All right. So now the function is continuous. Now let the function be anything here. One important thing here is it's a continuous function, and of course it's not mentioned, it's onto here, but let's see. Even if it's not onto the entire range, okay. Let's say I draw this function, then there will be one point, at least one point there's the line y equal to x. There'll be at least one point where the function cuts this line y equal to x. So there will be, so here this will be x. This will, because this point is y equal to x value and y value will be the same. So we get f of x is equal to x. The function value is equal to itself here, because again it's a property of continuous functions. All right. Now intermediate mean value theorem, intermediate value theorem is actually a more general statement of the the 5th case. It says if a function is continuous on closed interval AB, then it takes all values, all intermediate values between f of A and f of B on open interval AB. So I'll do this one. So f of A, f of A and B. Let's say this is f of A and this is f of B. Now, this is the value of f of A. This is the value of f of B. Okay. What intermediate value theorem says is function is continuous. Okay. So we have to join this point and this point without lifting the pen. Now, no matter what I go, what trajectory I go, I may go outside of this, but we can see all the intermediate values between f of A and f of B. All right, all these values are taken by the function. That is what is the intermediate value theorem. Okay. These are very useful ones to find roots, and also for general aptitude also analysis. It's very useful. So the fifth one, where this particular result, where f of x has at least one root in open interval AB, it's just a consequence of the intermediate value theorem. There, if f of A and f of B are of opposite signs, then f of x, f equal to 0, function value equal to 0 will be one of the intermediate values. Okay, that is about intermediate value theorem. So these are properties, very useful and important.